Good morning, physics. It's Mr. Craich. We talk about projectile motion and specifically the Wile E. Coyote problem. Probably the most easy of the projectile motion questions that you're going to find. If you were in Physics 11 last year, you will have remembered that we did problems like this, but we just didn't do trigonometry and Pythagoras to them at the end. And that's really the only difference between Physics 11 and Physics 12. We will find out what the true velocity is just before the sled hits the water, and we'll also find the angle at which it hits the water. So here we go. I chose to go with a problem from the Grinch, and it's very similar to Wile E. Coyote when he chases the Roadrunner around a corner and the Roadrunner makes the curve but the Coyote doesn't and he goes flying off the cliff. It's the same thing on the Grinch. In that movie, the Grinch is going down from the top of Mount Crumpet and makes a curve, surprisingly, even though it was very snowy and probably icy, but still made the curve. But in reality, he would have gone flying off the cliff and done projectile motion all the way down into the water here. Sled and Max the dog and the toys would all hit the water, and they'd be hitting it at about that angle. So what we will do is find out what the true velocity is if you radar gunned him just before he hit the water, and what that angle of impact is. A problem like this, projectile motion, it involves two directions, vertical and horizontal. Just like any problem, you want to isolate what you're looking for, and from the problem, write down what you know too. And then from that, you can pick an equation to figure out what you're looking for. So in this particular example, it has the Grinch flying off the cliff at 11 meters per second. The cliff is 15 meters high, and the questions could be a whole bunch of different ones, but let's just write the facts down first, then we'll get to the questions in a minute. So D in the vertical direction was 15 meters, but fell 15 meters, so negative 15 meters. VI in the vertical direction, he just went off the cliff. And just like you stepping off a cliff, your initial speed would be 0 meters per second in the vertical direction. Your final speed, we don't know. That'll probably be one of the questions they ask. The acceleration in the vertical direction, it's the only acceleration that the sled feels. It's gravity pulling the sled and everyone down with it. And on Earth, that's minus 9.8 meters per second squared. And the time, we don't know it, but that's a vertical problem too, because gravity is causing it to fall. That's probably a question they'll ask. The time that you get from vertical is the exact same time as it would be in the horizontal direction, because it doesn't matter whether the sled goes out like this and hits the ground or just fell off and straight down and hit the ground. They'd hit the time or hit the ground at exactly the same time. Horizontal, the distance that it travels from the cliff to where it hits is called the range. And that range is right here. So from cliff to the point of impact right here. And that would be one of the questions that they would ask. The V initial in the horizontal direction, it's 11 meters per second when it left the cliff. And in projectile motion, that doesn't change. So it's still 11 meters per second just before the sled hits the water. And the acceleration in the horizontal direction didn't speed up or slow down. So it's 0 meters per second squared. So there are a few rules here for projectile motion. One, the acceleration in the vertical direction is minus 9.8 meters per second squared, and the acceleration in the horizontal direction is 0 meters per second squared. That's on Earth. If it was on the moon, the vertical acceleration would be minus 1.6, for instance, but the horizontal acceleration would be 0. So the horizontal speed, initial and final, are exactly the same. Okay? The first question that they would ask, or at least one of at least 4 questions they would ask, is how much time does it take to hit the water? So how much time was that sled in the air before it hit the water? So we've got t that we're looking for. And we've got, so this is what we're looking for. And gravity's causing it to fall. Gravity's vertical, so it's a vertical problem only. So use vertical information to solve it. Well, luckily we know the d in the vertical direction, which is good. We know the vi. We don't know the vf. We do know the a, and we're looking for the time. So we need to use an equation that has d, vi, a, and t in it. Board, we have the 4 equations of kinematics. D equals VIT plus 1/2 AT squared, VF equals VI plus AT, and VF squared equals VI squared plus 2AD. And lastly, D is equal to VI plus VF over 2, which is the average velocity times time. So we need to have an equation that has D, VI, A, and T in it. And the only one that has that is that one right there. So we need an equation that doesn't have VF. The only one in there that doesn't have VF is that one. And that's the one that we need to use. So here we go. D equals VIT plus 1/2 AT squared. D is minus 15. VI is 0 in the vertical direction. 1/2 A is minus 9.8 times t squared. So just to clean it up, make it look a little better, this whole thing is 0. This is just half times 9.8, so it's minus 4.9 times t squared. I don't want t squared, I just want t. So I've got to divide this side by minus 4.9, so I'll do the same thing here. So minus 15 over minus 4.9 is equal to t squared. If you do that, go minus 15 divided by 4.9, it's about 3-ish, and then you have to root it. So make sure you root it. When you do that, you get this answer. This answer right here. T is equal to 1.75 seconds. So that's a big one. That's the first question answered right there. Second question coming up. A second question could be, what is the range? Like, how far horizontally does it land away from the cliff? That's a horizontal problem. Like, how far horizontally? So we have to use just horizontal information. So in this example, we have to use horizontal info only. So horizontal information is all right here. It's the same 1.75 seconds to fall, and I'm trying to find the range. So I could use a lot of different equations, but any one that has D in it is the one that I want to use. So I'll pick an easy one. I don't know, I could use this one. That one would be harder. That one doesn't even have D in it. But this one, I don't know, maybe it's okay. Looks pretty easy. So we'll give it a try. The fact is, though, if I get an answer from this, or this, or this, that D will be the same no matter which equation I used. So just putting the numbers in, D is equal to VI, which is 11, final speed was 11, divided by 2, all times the time, 1.75, and that gives me my answer for the range. And I got 19.25 meters, which rounds up to 19.2. Given that we have only two digits that are significant here, like 1598, it could even be just 19 meters. That's the accurate way of representing what that answer is. Could be. What is the final vertical speed? So how fast is that sled going vertically in the downward direction just before impact with the water? And to solve that, we're looking for this right here, the VF in the vertical direction. So that's the one we're looking for. We've got all the other variables, so I could pick any equation that has a VF in it and I would get the answer. But if I use this one, or this one, it doesn't matter which one you use, you'll get the same answer. I'll just pick an easy one to use. To me, that one looks like the easiest. VF equals VI plus AT. VF is what we're looking for. VI in the vertical direction was 0. Acceleration in the vertical direction is 9.8, and T was 1.75. So my VF turns out to be to get the hypotenuse, just use the Pythagoras theorem. So h squared equals a squared plus b squared. So I get this thing here, which is h, is equal to a squared, 11 squared, plus 17.2 squared. That's h squared. So what is h? What is that hypotenuse? We get 20.42. So the VR, the true velocity, if you had a radar gun on the sled just before it hit the water, was 20.4 meters per second. Let's get that angle. To get the angle, we have 90 degrees, thank goodness. So tan theta is equal to opposite over adjacent. So we got opposite here, adjacent here. There's the angle. Opposite, 17.2. Adjacent is 11. So that's tan theta. So doing the calculation is like 17.2 divided by 11 is 1.5636. If you go shift tan, make sure your calculator's in degrees, not rad or grad, you'll get 57.4 degrees. So the answer you would write for this particular question, what is that sled's final velocity? You'd say the final velocity, or V final, is equal to 20.4 or 20.42 meters per second at 57.4 degrees below the horizon, or below horizontal.